So where we left off was with letter G. You're supposed to figure out what f of -1 is first. Okay, so we're going to actually try to figure this out first. And then whatever we get, we're just going to add 4 to that answer. So in order to get f of -1, we have to substitute -1 into our f function, which would look like that. And then we just have to remember at the very end, we need to add 4. So really quick, if I just do -2 plus 5, I get 3. And then they want us to add 4 to that answer. So the answer is going to be 7. Same more deal with letter H. So they want us to do 2 times whatever h of 0 is. So you really have to remember that this is a set of directions. It's saying, hey, I want you to substitute 0 into the function and tell me what you get. So we have to do this first before we can multiply it by 2. So I'll just kind of keep the 2 there for right now. H of 0 would look like 5 times 0. And I have to remember to multiply my answer by 2. And it looks like my full answer, then 2 times 5 times 0 is just going to be 0. Letter I, again, we have an h function in the problem. So we need to evaluate h of 4 before we can do anything. And then we'll throw in the division symbol and the 10. So we'll just ignore that for right now. H of 4 means we're going to do 5 times 4. And actually, you should do that before anything. So you're going to get 20. And then they want you to take 10 and divide it by that answer of 20. So 10 divided by 20 is going to get you 1/2. So letter J is worded a little differently. It says find x if the function equals 16. So the function itself is 2x plus 5. And they're telling you that that comes out to 16 for some value of x, and your job is to figure out what that value is. So we're going to solve the equation, and just to save on time, we're going to get 5.5. So you actually could write this answer in function notation. These are both whole numbers, or excuse me, they're just both numbers, no letters. So we can go ahead and do this. We're going to say that f of my x in this example is 5.5, and my output was given to me, that was 16. Right, so again, we're not going to like divide by 5.5 on both sides. This is just a statement. This is saying the value of the function at 5.5 is 16. This is a sentence, so we can't change it. And if you wanted to make ordered pairs from that, you could write 5.5 goes with its output of 16. Same thing for the next one. Okay, it says find x if the function is 50. So we're going to take the h function of 5x, and we're going to set it equal to 50. And we're going to solve for x. So really quick, x equals 10 is my answer, which is awesome to get that. I'm going to challenge you to write your answer in function notation. So you could turn that into h of 10 equals 50. So when you plug 10 into the formula, you get 50 as an answer. And then as ordered pairs, you could graph this at 10, 50. Our next example is, it looks a little weird, but you got to keep in mind what your job is. Your job is to substitute x plus 3 into the function. So instead of 2x, we're going to replace it with 2x plus 3 plus 5. And then we're going to simplify as much as we can and then circle our answer. So we'll get 2x plus 6, add the 5, that makes 2x plus 11. So what I'd like you to do for m and n is give those a shot. Don't be overwhelmed. I changed x into y. It's the same situation. I changed x into k, same situation. So instead of x, just use the letter k and see if you can come up with something. So hopefully you set up 5y equals 13 and got 13/5. I did go ahead and write my answer in function notation. So if 13/5 goes in for y, 13 comes out as the answer. And that's what it'd be as an ordered pair. Over here, we get 7.5 for k. So if I put 7.5 in for k, I'm going to get 20 as my answer. So that would be my ordered pair. We're going to go through really quick and decide if these are functions, just practicing that vertical line test, because there's a little catch. these examples. So right away, I'm going to draw a vertical line, and that does definitely fail. So that is not a function. Same thing with C. It fails because it touches here and here. That's a no. Same thing with D. Touches here and here, so that's a no. Now, letter B, you draw vertical lines. It's not touching both functions. However, we get to this scenario. Right here, this vertical line is going to be an issue. So it looks like the answer would be no because it looks like it double crosses, but if you look closely, this point is not shaded. And rule of thumb is if a point is not shaded, it's not considered a real point on the graph. So we almost ignore it if it's not shaded. So it doesn't really have a value right here. So in this case, it does pass a vertical line test because this doesn't count. So this is the only point it touches. So this is a yes. Our last example is going to be comparing length of probably like a rectangle or something to area. So instead of x and y, we'll be using L and A. So we just want to get used to changing out our variables. So notice as length changes, your area changes. So your area gets bigger and then eventually it starts getting smaller again. So it first wants you to decide what does area is a function of length mean, and is a function of is really code for depends on. It's just a little bit more grown up. So area depends on length. So what that means, it says find A of 10. So that means find area if this is your length. So our function would be area depends on length. That's not A times L. It's not area times length. This means area depends on length. So they're asking, what is the area if the length is 10? So you're going to have to go down to your length chart, which here's 10. You have to go up till you reach your curve. So it looks like the area is 600. At that particular point, the area is always going to change. So we just want to make sure that we're focusing on the correct values. And then you're supposed to turn what this says into words. So we want to say area when length is 10. So now it's going to switch. Now it's saying find length if the area is 0. So you almost have to kind of ignore the L. Okay, we know area is based on length, but if the area is 0, they're asking what is the length. So you'll have to go to 0 on your area, okay? And you're going to circle all the spots where your little curved graph touches 0 high. So it also will happen over here. So both of these have a 0 area. So L actually can equal two things in this problem. So it can be 0 or it can be 40. And then they want you to turn these math sentence into words. So we're going to translate this, okay? It means area is 0 at certain lengths. I'm just going to make it so it could be length or length. So the area is 0 based on your certain length. And then letter F says, what point will the area reach its max? So it's pretty self-explanatory. Obviously, this is the highest area on the whole graph. So I want to start by writing, well, at 20, 800, we have max area. So the length is 20, that gives us the most area, which is 800, and then it says express this in function notation. So you're going to have to change it into area of a 20 length is 800. So the area based on the 20 length is 800.